Okay, so that was an example of graphical approach in solving a system of equation. But a more accurate approach is algebraically. So there are two ways of solving algebraic, there are two ways or two methods in algebraic solutions and for systems of equation. First one is called substitution. So let me give you an example of substitution. Let's say I have this system 6x plus y equals 1 and a negative 2x plus y equals negative 3. So here's a system and I want to solve it by substitution. So basically in substitution, you look at your system and you pick an equation, whichever is easiest to work with, and solve for one of the variables. It doesn't matter which variable you solve for. By the way, most of the times we use x and y, but sometimes you might see a and b as variables or other letters, or even from the Greek alphabet, alpha and beta and so forth. That doesn't matter. They're just symbols. Okay, so if you look at this system, which equation is easier to work with? Well, both of them are kind of easy. So I'm going to pick the second equation. And which variable in the second equation is easier to solve for? And if you look at it, you will see that it's easier to solve for y. So I'm going to take the second equation and solve it for y by adding 2x to both sides, and I get 2x minus 3. And then what you do is that you take the quantity you just that you obtained by solving for one of the variables, and you substitute it or plug it into the other equations, the other equation that you haven't touched, in place of that variable that you solve for. So I'm going to take 2x minus 3 and put it in place of y in the first equation, because that's what y equals to. So the first equation becomes 6x plus y, but now instead of y, I'm going to put 2x minus 3 equals 1. So this was your y. Okay, now why did we do this? Because if you notice now, the first equation only has one variable, and that's x, and I can solve for x. So I'm going to simplify. That gives me 8x minus 3 equals 1. I'm going to add 3 to both sides. That gives me 8x equals 4. I'm going to divide by 8. X turns out to be 1/2. Okay, and now how do I find the other variable, in this case y? So you can plug this back into one of the original equations, or you can plug it into the equation you solve for, which is easier, so you can solve for y. So equation 2, it becomes y equals to 2x, but we know x is 1/2 now, minus 3. Now what's 1/2 times 2? That's a 1. Minus 3, that gives you negative 2. So your y value is negative 2. So your final answer is 1/2 comma negative 2. So how many solutions do I have for this system that I solved by the method of substitution? I have one solution. If I were to graph these two equations, they would intersect at exactly that point. So you see, algebraic approach, whether you're doing substitution or elimination, is much more accurate. So that was an example of substitution. Now the steps for doing the substitution method is given to you on page 508. The steps for doing the substitution method is given to you on page 508. Okay, perfect. Now let's go to the method of elimination. That's the most prevalent or the easiest method that we usually use in solving systems of equations if you have a choice. If you don't have, if the problem indicates precisely what method to use, then we use that method. But if you do have a choice, I would recommend you always use elimination. So here's an example. 2x plus 5y equals 13. 2x minus 3y equals negative 7. Here's your system. Okay, so how do we do elimination? Oh, and the steps for the elimination method is given to you on page 510, at the bottom of page 510. So you can review those steps. Okay. First of all, you want to make sure that your equations are in standard form. That means they're in this form. That is, both variables are on the same side of the equal sign. And our system, our equations are already in that form. Then you look at your system, both of your equations, and see which variable is easier to eliminate. And by eliminate, I mean that the coefficients in front of those variables are equal in value but opposite in sign. The coefficients must be equal in value but opposite in sign. Doesn't matter which variable you want to eliminate. And once you choose that variable, then you add the two equations and excuse me, and those variables will be eliminated. So if you look, by chance, you can see that the x's have the same variable, same coefficient value. They're both 2's. One is negative, one is positive. So when I add equation 1 to 2, what's negative 2x plus 2x? Well, they cancel each other. 5y minus 3y, that's 2y, equals to 13 minus 7, which is 6. So when I divide by 2, I get y to be 3. And then how do you get x? You just plug the value you got back into one of the original equations. It doesn't matter which equation you plug it in. Just plug into the one that is easier to work with. So I'm going to plug it into equation 2 because that's smaller numbers. So I have 2x minus 3y, but the y is 3, equals negative 7. So that gives me 2x minus 9 equals negative 7. I add 9 to both sides. 2x equals to 2, or x equals to 1. So again, I have one solution for this system, and that solution is x comma 3. So you put it as an ordered pair. I have one solution. That means this point satisfies both of these equations. And if I were to graph these two equations, they will intersect at exactly that point. Okie dokie. Let me try one more example with elimination. Let's say I give you this. 2x minus 3y equals 7. 6y plus 5x equals 4. Okay. Well, one thing I have to mention as well. The variables have to be lined up. You see, y's and x's are lined up. So you want to rewrite them. So equation 1, equation 2. So I'm going to keep the equation 1 as it is. But I'm going to rearrange equation 2 in this manner. So I'm going to line up the y's and the x's. Okay, which variable would be easier to eliminate? You can either eliminate x or y, it doesn't matter. Now, if you chose to eliminate x, then you have to make sure that the coefficients are equal in value but opposite in sign. In this case, how would I make these two coefficients equal in value? I can multiply the top by 5 and the bottom by 2, and that will give me 10. So 5 times 2 is 10x, and 2 times 5 is 10x. But then one of those has to be negative, so I can maybe multiply the top by negative 5 or the bottom by negative 2. It doesn't matter as long as one of them is negative. You can do it that way. You can eliminate x. But if you look at the y's, look at the coefficients, the signs are already opposite of each other. So that makes it a little bit easier. And if you just multiply the 3 by 2, you get negative 6y here, which is opposite of positive 6y. So I'm going to multiply the first equation by 2. So first equation becomes 4x minus 3y. Oh, I'm sorry, minus 6y equals to 14. So you got to multiply by everything on both sides of the equation. Second equation stayed the same. So you have 5x plus 6y equals 4. Now you can add them. These guys cancel out. And what do you get? You get 9x equals to 18, or x turns out to be 2. And then you plug it back into one of the original equations. Let's plug it back into equation 1. So x is 2, so you have 2 times 2 minus 3y equals 7. That's 4. And I'm going to subtract 4 from both sides. So I'm going to have negative 3y equals to 3. Divide by negative 3. Y equals negative 1. Here you go again. One solution. X first, y second. And there's the solution to the system. Now, you don't always get one solution. Now, sometimes you get no solution. Now, how do you get no solution? That's when, for example, when you are eliminating, let's say you eliminate here, and everything gets eliminated, and you on the left side, the x's and the y's. Let me give you a quick example. Let's say I have negative 4x minus 6y equals 14, and I have 4x plus 6y equals 4, and I just made up that example. If I use elimination, you see everything cancels out, so I get 0. But on the right hand side, I get 18. 0 obviously does not equal 18. Therefore, if you get a situation like that where you end up with an incorrect statement, like 0 equals 18 or negative 1/2 equals 5 or something like that, then you have no solution if you get an incorrect statement. On the other hand, let me give you this example. Let's say you have negative 4x minus 6y, 4x plus 6y equals to, let's say, 14 and negative 14. And I add these guys up. These guys cancel out, you get 0. These guys cancel out, you get 0. So you get, what did you get? You get a true statement. Does 0 equal to 0? Yes, it does. So if you get a true statement where everything else cancels out, then you have infinitely many solutions. Or if you get 5 equals to 5 or negative 2 equals negative 2, doesn't matter. If you get a true statement when everything gets canceled out, then you have infinitely many solutions. If you have an incorrect statement like this, when everything cancels out, then you have no solution. And if you get a one solution like these examples we have been doing, then you have one solution. So you still get those 3 possibilities. All right, let's see. Let's try problem number 70 on page 518. Problem number, so this is page 518, number 70. So let's go to that page. And problem 70 says a dietitian needs to mix 10 gallons of milk that is 2.5% milk fat for the day's rounds. He has some milk that is 4% milk fat and some that is 1.5% milk fat. How much of each should be used? Okay. So usually for these type of problems, mixture problems, I do a little visual for myself. It makes it easier. Okay, so he has 2 types, or she has 2 types of milk and wants to get a new mixture. It says a dietitian needs to mix 10 gallons of milk that is 2.5% milk fat for each day's rounds. So that is, so you have 2.5% milk fat and you want 10 gallons. Okay. He has, so it's a he has milk that is 4% milk fat and some that is 1.5% milk fat. How much of each should be used? So we don't know how many gallons of the 4% we have to use, and we don't know how many gallons of the 1.5% milk fat have to be used. So we have 2 unknowns. If you have 2 unknowns, you need a minimum of 2 equations. So we end up with the system. If you have 3 unknowns, then you need a minimum of 3 equations. Okay, so how do we write this system? So these are gallons, X gallons, Y gallons. I know if I mix X gallons with Y gallons, I have to get 10 gallons. So here's my first equation. X plus Y equals 10. Because those are all gallons and the units have to match. The second is, the first one has 4% milk fat. So can I write 0.04x plus 0.015y equals 0.025 times 10. So I'm just calculating the milk fat. Okay, so here's my system. Now I want to simplify it a little bit. I don't like working with decimals that much, so let me rewrite it again. So x plus y equals 10. Can I multiply everything by 100? So this, if I multiply this by 100, the decimal place moves to the right 2 spaces. So that's 4x plus 1, 2. Actually, let me multiply it by 1,000. So I don't have to work with decimals at all. So 1, 2, 3. So that's 40x. 1, 2, 3. That's 15y. And let me see. What is 0.025 times 10? That's, well, it has 1 0, so it moves 1 space. But if I multiply that by 1,000, I will get 250. There's my system. Voila. Okay. So if that's my system, how do I solve it? I would recommend elimination again. So let's eliminate y. How can I eliminate y? Well, look at the coefficients. That's 15, that's a 1. So if I make this coefficient into a negative 15, then negative 15y and positive 15y will cancel each other out. So I'm going to multiply the first equation by negative 15. So first equation becomes negative 15x minus 15y equals to negative 150. So don't forget to multiply both sides of the equation by that factor. Second equation stays as it is, 40x plus 15y equals to 250. Add them up, cancels. This gives you 25x, and this gives you 100. So x equals to 4 gallons. So you gotta mix, so you have to have 4 gallons of the 4% milk fat, milk. So if I have 4 gallons here, how many gallons should I have here? So I can have a total of 10 gallons. Then obviously y has to be 6 gallons. So we solve this equation by the method of systems of equation and using elimination. Okay. Let's move on to problem number 82 on this page 519. So let me show you the problem, number 82 right here on page 519. It says a competition in the smartphone market is often fierce. You know what? Let's do that one together on Tuesday. Yeah, that's a good one to do together on Tuesday. So if you have a chance, try to work on 82 beforehand, before Tuesday, and let's see what we can come up with. Okay, you son of a gun saw the answers, didn't you? Ha ha ha. Well, anyways, okay. Now, sometimes you might have systems of 3 equations. So let's say I give you this. 2x plus y minus 2z equals negative 7. X plus y plus z equals negative 1. And then negative 2y minus z equals negative 3. Now I'm not going to go into solving systems of 3 equations. You can use graphing calculators to do that. But what if I give you this? I mean, we are going to solve systems of 3 equations a little bit later, but simple ones. This one takes a little bit of time, and I don't want you guys to spend too much time. If I give you this point, is this a solution to this system? Well, how do you check? Well, you just have to plug it in. And by the way, this before we had like this, when we solve systems of two equations, we had an ordered pair as an answer if you had one, if you had a solution. This is called an ordered triplet. So this is your x, this is your y, this is your z in alphabetical order. So you just have to plug them in all three equations, see if it works. So equation 1, equation 2, equation 3. Equation 1, let's try it. 2 times x, which is -3, plus y, which is 1, minus 2 times 1. Does it equal to -7? I put a question mark there. I don't know. Let's see. This gives me -6 plus 1 minus 2. That gives me -8 plus 1. Yes. It gives me -7 equals -7, so that's correct. So equation 1 checks. If one of the equation doesn't work, you stop right there. If it has to satisfy all three equations, otherwise it's not a solution. Equation 2, you have x, which is -3 plus 1 equals -1. Does that give me -1? I don't know. -3 plus 2, does that equal -1? Yes, it is. So that also checks. Now, finally, we have to check the last one, equation 3, -2y, or I know y is 1, minus z, which is 1. Does that give me -3? Yes, it does. So -3 equals -3, check. So this point satisfied all three equations, therefore it is a solution to this system of three equations. Okay, so I'm going to stop right there.